In this video, we're going to continue topic 6.9, which we were talking about u substitution. We're going to look out in this left-hand column first. So to use a u substitution with definite integrals, replace the bounds on the integrals that represent the x with new bounds that represent u, sorry, not x, u. To do this, substitute numbers into your u equation. All right, so let's check this out. So first of all, we got to figure out what u is going to be. So I would say whatever's under this radical is probably going to be u. So u equals 3x plus 10, meaning that du equals 3 dx. And actually, we have 3 dx. Let's rewrite just a little bit here. So we have, I'm going to rewrite the whole thing. We know that this is going to be our u. But we could rewrite this 9 as 3 times 3 dx. Check that out. So I actually have 3 dx. So, and then this 3 here could be brought outside. So now let's do the u sub step. So I'm going to bring that 3 outside. And then we've got the 4th root of u. And then the 3x dx gets replaced with 1 du. Perfect to integrate now, except that we need to change our bounds. And the upside of changing our bounds is that we don't ever have to put the u back in when we do that if we're going to change them to u bounds. So I'm going to use this lower bound first. We're going to put it into the u equation. So we're going to say for x equals -3, we're going to do u equals 3 times -3 plus 10. 3 times -3 is -9 plus 10 is 1. So my new lower bound is 1. Okay, my new upper bound, so I'm going to replace the 9. So for x equals 9, I'm going to go u equals 3 times 9 plus 10. 3 times 9 is 27 plus 10 is 37. All right. I did something completely wrong. What happened? That was... All right, so it turns out that I actually have a typo in here, which is why this wasn't turning out the way I thought it would. So we're going to fix the typo. So it's not going to be x equals to 9. We're going to make that 9. We're going to actually get rid of that 9. A little bit of white out there. And we are going to make it a 2. So that should have been a 2 all along. All right, so we're going to take that 2 and we're going to substitute it in. So x equals 2. So u equals 3 times 2 plus 10. 3 times 2 is 6, plus 10 is 16. So my new upper bound is 16. It's going to work out a lot better for us. All right, before I can integrate this, I'm going to bring this upstairs. I'm going to actually convert it to the 1/4 power because it's really like saying u to the 1/4, and then I need to bring that upstairs. So I'm going to do that all kind of in one step. So I'm going to have u to the -1/4 du. Now we are finally ready to integrate. So we're going to add 1, which is 4/4. And I don't know why I'm writing my integral symbol. So we get u to the 3/4 from 1 to 16. And now we're going to go ahead and plug in the 1 and the 16. And that's the bonus of switching to u's, is because I don't have to go back in and plug that u back in and then switch my bounds again. I can just plug in right here. It's kind of a cool little bonus. So I've got 16 to the 3/4 minus 3 times 1 to the 3/4. All right, so I'm going to rewrite the 16 as 2 to the 4th to the 3/4 minus, and we know 1 to any power is just 1, so this is 3 times 1. Let's see, the 4ths go away. 2 cubed is 8 times 3 would be 24. 8 times, sorry, what happened? I got a 3 out in front somehow. Oh, when we integrated, I messed up. Let me go back again. Apparently, I can't do anything in this problem. when I integrated, I did not remember, let me find a different number, to divide by my new exponent or multiply by its reciprocal. So let's go back to that, which means that these guys would cancel. So what I really have is 4 u to the 3/4 from 1 to 16. And we're going to go ahead and plug in the 1 and the 16 again. So 4 times 16 to the 3/4 minus 4 times 1 to the 3/4. So again, I'm going to write 16 as 2 to the 4th to the 3/4 power minus 4. These guys cancel. 2 cubed is 8. 8 times 4 is 32. Minus 4 is going to be 28 as our final answer.